Today our topic is perfectly elastic collision in one dimension. So first A is laboratory frame. Principle of conservation of linear momentum m1u1 plus m2u2 is equal to m1v1 plus m2v2. This is first equation. So according to law of conservation of energy, m1u1 square plus m2u2 square is equal to m1v1 square plus m2v2 square. This is our second equation. Now rewrite and arrange first and second. So taking m1 common, u1 minus v1 in the bracket is equal to m2 v2 minus u2 in the second bracket. Now m1 u1 square minus v1 square is equal to m2 v2 square minus u2 square. This is fourth equation. Now dividing fourth equation by third equation. So m1 u1 plus v1 is, so as we know the formula of identity equation, a square minus b square is equal to a plus b, a minus b. So now after that we get u1 plus v1 is equal to m v2 is plus u2. Now taking the initial velocity in the left, u1 minus u2 is equal to minus v1 minus v2 in the bracket. Now velocity after collision, v1 is equal to v2 plus u2 minus u1 and v2 is equal to v1 plus u1 minus u2. Now put v2 in equation third. So m1, taking m1 common, u1 minus v1 is equal to m2 v1 plus u1 minus u2. Now taking v1 common, m1 plus m2 is equal to m1 minus m2 u1 plus 2 m2 u2. Now our v1 will be, our final velocity will be m1 minus m2 upon m1 plus m2 u1 plus 2 m2 upon m1 plus m2 u2. This is equation 6. Now v2 is equal to, in the same way we can write for v2 also, m2 minus m1 upon m1 plus m2 u2 plus 2 m1 upon m1 plus m2 u1. Now the case first is, if m2 at rest, then u2 is equal to 0. Then v1 is equal to m1 minus m2 upon m1 plus m2 u1 and v2 is equal to 2m1 upon m1 plus m2 u1. This is equation 8. Now case second, if m1 is equal to m2, here in case 1 m2 was at rest and u2 0. Now case second, m1 is equal to m2. Then what will happen? Put it in equation 6. Now v1 is equal to u2 and seventh equation, v2 is equal to u1. If m2 is also initially at rest, then u2 is equal to 0, since v1 is equal to 0 as before v2 is equal to u1. Hence first particles of mass m1 comes to rest after collision and second particle of mass m2 acquires the initial velocity of the first. इसमें केस m2 में हमने क्या देखा कि फर्स्ट पार्टिकल जिसका मास m1 है वो कोलिजन होने के बाद रेस्ट पोजीशन पे आ जाएगा और जो सेकंड पार्टिकल इसका मास m2 है वो फर्स्ट पार्टिकल के मास को एक्वायर करेगा, उसकी वेलोसिटी को एक्वायर कर लेगा. नाउ केस थर्ड क्या है? m2 इज़ वेरी वेरी ग्रेटर देन m1 एंड u2 इज इक्वल टू 0. Then m1 is equal to 0, m1 minus m2 is equal to minus m2 and m1 plus m2 is equal to m2. Since v1 is equal to minus u1 and v2 is equal to 0, when light particle collides against a very massive particle at rest, the heavy particle continues to remain at rest and velocity of light particle is reversed. Okay. इसमें क्या है, अगर m2 उसका भार, m2 यानी जो पार्टिकल है उसका भार ज़्यादा है तो वो अपने रेस्ट पोजीशन पे रहेगा, लेकिन जो लाइट पार्टिकल है उसका जो वेलोसिटी है वो रिवर्स हो जाएगा, किसी और डायरेक्शन में चला जाएगा. केस फोर्थ क्या है? पार्टिकल एट रेस्ट इज़ वेरी लाइट. पार्टिकल जो रेस्ट पे बहुत हल्का है, तो यानी m2 ज़ीरो है यहाँ पर और m1 माइनस m2 इज इक्वल टू m1 आपका हो जाएगा, क्योंकि m2 यहाँ पे ज़ीरो है तो आपका सिर्फ m1 बचेगा. एंड m1 प्लस m2 इज इक्वल टू m1। दोनों वो m2 यहाँ पे 0 है तो m1 प्लस 0 इज इक्वल टू m1। So this is about the perfectly elastic collision in one dimension.